Alright guys, so today I'm going to be talking about this. We've done a previous video on one example, so we are looking at another example on incline plane. Alright, a concrete block of mass 25 kg is placed on a wooden plank inclined at an angle of 32 degrees to the horizontal. Calculate the force parallel to the inclined plane that will keep the block at rest if the concrete if the coefficient of friction between the block and the plank is 0.45. So I told you the first thing first, you draw your sketch. Our sketch goes like this. This is an inclined plane, and this comes here. Make sure your hand is straight. Sorry, I need to redraw. My hand is not straight. Alright. So this is my object. Here I have my angle theta. What was my angle? My angle is what? 32 degrees. Alright. So here I have my what? Horizontal. This is my horizontal component. My horizontal component is what? W sine theta. Don't forget. So this is my CG. So my vertical component is what? My vertical component is okay, let me just put it, okay. Let me put it this way. I can leave it here. My vertical component is W cos theta. So this is my reacting force, right? And here I have my W. All right, that's it. Okay, so here we have our frictional force F. F is equals to mu R. Don't forget, that's it. All right, you can see the diagram is very clear. No stress. So this is the first thing you should always do. Imagine I have 20 degrees, I'll put 20 degrees here, then this same thing follows. That's it. Anyway, let's get down to business. So what are we having our parameters? We are having theta to be equal to 32 degrees, and we are having our mass to be what? Our mass to be 25 kg, and we are having what? Our G to be equal to 10 meter per second square. And what else are we having? We are having okay. We are giving our coefficient of friction to be 0.45. They have given us. We don't need to find it anymore. So the only thing we suggest we find is our weight force. Then our weight force is what? Mg. That's what? Our 25 multiplied by 10. They gave us 25 here. So that's what? 250 Newton. Alright. So our weight force is what? 250 Newton. Alright, so now, they said something and they said calculate the force parallel to the inclined plane that will keep the block at rest. So the force, let Fr represent the force that will keep the block at rest. Whenever you are asked to find the force that will keep a block at rest in a question like this, so what to come to your mind is that the force that will keep the block at rest to be F subscript R is equals to what? Is equals to the parallel component of what? Of weight. The parallel component of weight minus your frictional force. Is as simple as that. If it's the force that we move the block up, or that is required to pull the block up the plane, is going to be plus. But if it's the block that is if it's the force that is required to make the block come down, or the block should be at rest, it's always negative. That is the logic. Do you get it now? That is just the logic. If you are not getting it, rewind this. Alright, so then when we expand this, we have what? The force that is going to move the block at rest is what? What is the equation that satisfies this statement? That's W what? Sine theta minus what? Minus the frictional force. And you know clearly that this one is W sine theta minus, if you remember clearly that F is equal to mu R. Do you remember? Because from coefficient of friction, F over R. So when we cross multiply, this one becomes a follow formula. So we have substitute this Then we have this. Alright, so if we go further, it is stated that our mean is 0. What is 0. They give us our coefficient of friction as what is 0.45. So our coefficient of friction is 0.45. So we substitute here, and f of subscript I equals to W sine theta minus 0.45 r. Alright, no stress. So we can proceed further. Also we know that our r is equals to, see, r is equals to we are opposite. So whatever you have here is here, whatever you have here is equals to here. So our r is equals to W what? W cos theta. So which means that we are going to input this one into this side. We are having S subscript r is equals to W sine theta minus minus 0.45 W cos theta. No stress. So F subscript r is equals to, what do we have for W? We have 250 sine what? Sine 32 degree, because our angle is 32 degree, minus what? Minus 0.45 into what? 250 cos 32 degree. So let's solve this problem. Alright, so 250, okay, sine 32 is what? 25 into 0.5299 minus 0.45 into 250 into what? What was our cos 32? Cos 32 is 0.8480. So here we multiply. So let's multiply. Alright, so 25 multiplied by 0.5299. So that's going to be that is going to be 13.2475 minus. Oh, I noticed that there's a mistake here. 250, sorry. 250 times 0.5299. Okay, I noticed there's a mistake. So that's 132.475 minus 0.45 times 250 times 0.8480. Let me check again. 0.45 times 250 times 0.8480. So we're having what? We're having 95.4. So F over R is equals to what? Equals to, now let's subtract. We're having 132.475 minus 95.4. So we're having what? 37.075. So which is approximately 37.1 Newton. So that is the force required to keep the object at rest. So this is my number. You can chat me up for online class 0705967640. So you cannot escape all these kind of questions. So you can chat me up, and remember, I'm going to like to talk. Okay, I believe that this is well explanatory. So if you don't get it, you can calm yourself down and replay this video. You can download it. Obviously, you can download it on your gallery. How do you do that? You can just go on www.savefrom.net. So when you open this site, you will see a search button. You see a search tab. So before you go to this site, you just go beneath this video. You see where you have share. When you click on share, you see where you have your copy URL, and you click on copy URL, it will copy. And you now search for this website. Then you paste this inside the box. Then you load it. You see a loading icon there. You load it. Then it will take you to where you can download it. You save that to your phone in case you want to watch later to reduce your data. Alright, thank you guys for watching.